I'm going to be doing a series of videos on the unit circle and how to evaluate trig functions using the unit circle and all sorts of good things. But I'm going to start. Oh, by the way, this is the unit circle. So I'm going to start with some special right angle triangles. And we're going to work in degrees initially, but then we're going to move on to radian measure. And I'm going to explain everything as I go along. I'm going to try to make these quick, but we'll see what happens. Now, imagine that this is an equilateral triangle. And I can say the sides are any length I want as long as they're all the same. So I'm going to say that this side is 2a and this side is 2a. And you might be thinking, well, that's kind of a weird thing to say, but that's fine. So that's 60, and then obviously the angle from the vertex out to here would be 60 degrees, but I'm going to cut it in half. I'm going to use a perpendicular bisector. And when I do that, this becomes a right angle, that's 90, which means that this is 30 degrees. Because I've just bisected the base, we'll call it base AC at D, because I just bisected AC at D, this is A, which means I can now find out what is this here. And the way I'm going to do that is I'm going to say A squared plus that unknown side squared is equal to 2A squared because of the Pythagorean theorem. Now this becomes A squared plus my unknown side squared equals 4A squared. I'm going to subtract A squared, and I get my unknown side squared is equal to 3a squared. I square root both sides, and I'm left with my unknown side is equal to square root of 3 times the square root of a squared, which is a. So it becomes, my unknown side becomes a radical 3. Now, I don't particularly like this picture, so I'm going to redraw it to the best of my ability. And you can see across from the 30-degree angle is A. My hypotenuse is 2A, and my the side opposite 60 degrees ended up being A radical 3. Now, if I were to divide both sides, or all sides, by A, I would rewrite this as... Now I'm dividing all the sides by A. This would be 2, this would be 1, this would be 1 radical 3. And once again, this is 30, this is 60, and that's 90. Now I'm going to do another triangle. And this one's going to be... I'm going to start with the square. I'm going to... Oh, well, that was unfortunate. I was going to... No, I guess it doesn't matter. I'm going to cut the square in half, which would mean this is 45 degrees, and this is 45 degrees. And now, if I said, well, let's say that the two sides are both A, I'd get A squared plus A squared equals my unknown, I'm going to call it X squared. So I have 2A squared equals X squared. If I take the square root of both sides, the square root of 2 is radical 2, but the square root of A squared, is just A, which means my hypotenuse ends up being A radical 2. So I'm going to redraw that. And if this is 45 and this is 45, I get A, and A radical 2. Once again, if I were to divide this, if I were to divide all three sides, ooh, that doesn't look good. If I were to divide all three sides by A, I'd get 1, 1, and radical 2. Now, I'm going to pause there. I'm going to end this video. And then the next video, we're going to pick up we are going to talk about converting degrees to radians.